Okay. Is it visible? I think I can cut off my video. Is it visible to everyone?
Yes, sir.
Am I audible?
Yes, sir.
Yes,
It's
sir. It is
visible.
audible.
Okay. Good afternoon, guys. Very good afternoon to all of you. And thank you for joining this session. And some of the points Professor Sachin has exaggerated. I'm really humbled to hear all these words. Maybe out of curiosity or out of respecting it, I've added some certain things. Okay, anyway, it's a good thing that we are able to meet today. And my topic is automotive sensors, the sensors used in automobiles. And when we talk about the sensors, we have to talk about the whole system. So that's a problem. Anyway, I'm trying to limit my discussion to the sensors itself, not more than that. Okay, when you look at the today's car, you see that a lot of it's very difficult to understand terminology is being used to describe the functions and the facilities in a car. Sometimes we ask the salesperson, he doesn't know what is it, but he will say that ESC is there, electronic stability, ESP is there, electronic stability program is there, but he doesn't know what is that, what is what. So most of the technologies used in today's car is really highly technical and it's very difficult to understand by common persons. So this figure depicts some of the sensors that is available in a normal car. To underline the word normal car. If you go for autonomous car, some more sensors are coming into picture. So you might have seen some of the YouTube videos which explains or shows how the ABS is helping you to drive in a better way, or a traction control, or an electronic stability program, active suspensions. So many areas are there. So many control systems are there. And I was told that a BMW vehicle uses more than 125 electronic control modules. That is a module itself. What we use in a normal car is around 12 to 15 modules we are using. Imagine that if you have 125 modules and associated sensors, associated electronics that is involved, it's highly unimaginable. And the length of software program, one of the engineers was telling me that the length of the software program is more than the length of the program that they are writing for a rocket launcher for a space vehicle. So they are writing so much of the software program to ensure that the vehicle is running smoothly, safely, comfortably on the road. Okay, so just look at the various facilities starting from automatic braking, electric power steering, electronic control valve, electric valve timing, then idle speed start-stop system, which is recently introduced by Nagendra and followed by everyone. And cylinder deactivation and another new technology pursued by many automobile manufacturers who like to downgrade the engine when it is not required. And then obviously that the OBS, active vibration control, where they introduced dampers to reduce the vibrations, and then blind spot reductions, remote keyless entry, OBD, and then lane departure warning, like again a new addition where your driver will be intimated or warned about the lane that you are departing. So if, suppose you are following a multi-lane road, and if you like to go away, or your vehicle is going away from this unintentionally, that's the important word. Unintentionally, if the vehicle is going into the crossing the lines, then you will get a warning. Okay, and then transmission control, automatic transmission control, upshift, downshift, and then neutral position. All things are happening without our knowledge. The seat position control and another high-end car facilities. So just by measuring your weight, it will automatically adjust. It will identify who are you, and then what is your normal preferences. What is the angle of inclination? What is the front leg room? All these things under develop the seat heating and cooling, the ventilation preferences. Then electronic stability control, which helps you to travel at the even stable conditions, even though one wheel is going down in a potholes or going up in your speed breakers. And then another is active yaw control, which is used in wet grounds as well as in ice, snow fields, snow covered roads. Active yaw control, or also when you have a sudden turning of the vehicle for avoiding certain cover. This is a very important function because most of the accidents do happen while trying to avoid a small cyclist or a two-wheeler person, and the entire vehicle goes in a spin, and sometimes a very big accident happens. The vehicle will go and hit a tree. So to avoid this, we do have the electronic stability control, active yaw control, and then stability control. Then rear parking systems, park assist systems, which will help you to park the vehicle without getting down and seeing again what is there. And some modern vehicles do park, you just leave your steering wheel and automatically the vehicle will travel up and down, and it will nicely get into place in the parking system. Automatic parking system is also being introduced. And then active tire pressure monitoring system, it monitors continuously your tire pressure and tells you what is the current position of the tire pressure, and if it is low, there are such systems which actively fills the tire and the air so that the pressure is maintained. And there is an indication in your dashboard also about this. Then regeneration braking system, where during braking, the braking energy, deceleration energy is being converted into electrical energy. So this is happening mostly from the electric vehicle concept, where the motor will act as a generator, can be converted easily into generator. So you have regenerative braking system. Then hill hold control, another additional new feature, and in some countries it has become a standard feature and statutory requirements. Where when you travel in a uphill and if you experience heavy traffic, and always you have to press the brake, and then when you want to move the vehicle, you release your leg from the brake and go for acceleration. That's a very tricky issue, and by the time you accelerate and keep the vehicle or move the vehicle forward, probably few feet your vehicle might have traveled back or moved back, and sometimes it may lead to accidents. It may go and hit the front end of the vehicle that is following you. This happens, and it's a really a tricky issue for the drivers to hold the vehicle in a hill and move forward, okay, in a heavy traffic conditions. So you just press a button and it will automatically, the hill hold control will come into picture, and you can take off your legs. You can literally wait for this. When you want to move, just press the acceleration. That's it. We need not worry about the braking controls, brake controls. That has been taken care by the hill hold control. The vehicle will not allow the system will not allow the vehicle to move rear form in a reverse condition. So they're doing this hill hold control. When you want to move forward or go for a normal condition, switch off this facility. That's it. Then you have the active suspension. I told that the suspension spring rate is been actively changed by adjusting the hydraulic pressure or air pressure in a suspension system. And then active exhaust noise suppression. So depends on the zones that you are traveling, and your noise level has to be reduced. It is also a statutory requirement. And so the suspension, the rear exhaust gas, your pipes has to be tuned in such a way that the noise is being suppressed. So that has been actively done, because whatever the exhaust muffler that you are adding, that has been designed for a particular operating conditions. That's the existing mufflers problem. The mufflers are tuned for a particular speed and load conditions. And if you want to operate at a various speed and load conditions, the speed your mufflers will not be able to function properly. And so you have an active noise suppression system which changes the length of the muffler or by adjusting the muffler area as well as the length, it is able to muffle out all the noises coming from the engine at all speed ranges, all load ranges. So that is the active exhaust noise suppression. Then security systems which will help you to protect the vehicle and also to help you to stay safe. Even somebody wanted to attempt to open the door and then get into the car, the security system will give out a warning, and sometimes it will automatically dial the nearby police helplines or traffic control areas. Control rooms will be intimated about your trouble. Okay, then digital turn signals. Obviously, everyone knows about that turn signal. And you put on the signal and move in a curved path or in a corner, then automatically you will straighten your steering wheel. The light will be switched off. This is a very common feature you found in most of the cars. So the turn signals gets digital and automatically switches on when you go in a straight line. Then the recently added electronic toll collection systems that you put into your car and then you charge the account, and then when you travel through the fast track, automatically the amount will be detected. So that is also been added to now, and it is linked to your mobile number and bank account. Then lane correction. So this is a different from lane departure warning system, where this feature will do minor adjustment in your steering, so that always the vehicle is following in a particular lane. It's like a system available in a line following robot, where the robot try to follow the line meticulously without deviating. So when it deviates, then automatically it adjusts to the steering and comes back to the normal position. The same thing happens here. This is again a new feature where the lane keeping is being done by the assistance of this system, where minor steering adjustments have been done so that the vehicle will not depart from the lane. And suppose if you want to change the lane, and then you can change it by overcoming this system. So that's possible. Then another new addition that is coming forward now is our battery management system. Earlier we fitted battery and we forgot about it, but now the requirement coming from the batteries become so huge that a separate battery management system is required to take care of that battery volt charging and discharging, and then the output coming from the battery should not be excessively, it should not drop from battery, and it should not excessively charge the battery also. So you know the battery management system. Entertainment system, obviously, this is right from the beginning. You have so much of video, audio systems being fitted into this. Now they are getting intelligent and being controlled by voice or emotion. So you can switch on the particular video, your particular channel of the TV, and everything is available in your car. And then driver short range assistance system, DSRC control. Driver's short range control system assistant. Yes,
Hello?
yes, please. Yes.
Hello, sir.
Yeah, tell me.
So your slide is not changing, sir.
Yeah. I'm just explaining the system that's available in your car.
Okay, sir.
And that one by one I am just.
Okay, sir.
If you follow the anti-clockwise direction, you'll find out this one by one. I am explaining. Just a few lines about each system, because you might have heard about DSRC. What is a DSRC? You may not be knowing. Even after attending the class, then you should not go without knowing that what is what in your car. Okay. So I assume that most of the students are general students coming from different branches of engineering, and so I'm not assuming that you are a lot of automobile engineers. So I want to introduce what is the feature available in your car. Is it okay? I'll take few more minutes, and then we'll go to the other slides. The next one is the DSR system, driver's short range control system, where the certain sensors will be used to assist the driver in a short range driving positions. And then environmental control, like the climatic control in a car, voice data communication systems in a vehicle, so that helps you to communicate with other facilities available inside the car, and then other through internet you can communicate with others. Then active cabin noise suppression, that's also being introduced now. The cabin noise level can be adjusted by introducing this, by actively introducing suppression systems. And some vehicles have been equipped with anti noise sources, where it will try to identify the frequency of the noise, and an opposite frequency will be generated. Noise will be generated that will nullify the noise. And interior lighting, that again depends on the reading light and then your preferences. Colored lighting, LED lightings are there, and that's controlled by a separate ECM. And then auto dimming mirrors. So this is the new feature being added. So what happens when most of the drivers who are driving during night time, might have experienced that the vehicle, oncoming vehicle from behind you will have the headlamp switched on. So that light will get reflected in your mirrors. So that is going to create a nuisance, or make it difficult to drive under these conditions. So this reflection or coming from the behind vehicle can be dimmed by changing the reflective nature of the mirror. So that's also available now. And then separate event data recorder is there, apart from the OBD2, and now they introduce the event data recorder. Any special events will be recorded by this, and will help you to identify the trouble in your vehicle. And then accident recorder, another new feature will be added. So it will record the what is happened during the accident, what was the vehicle speed, what was the other parameters of your car, and what may be the reason that the accident has happened. So electronically it will look into the various parameters and record this last minute data like a black box, to act as a black box, and then tell you why or how the accident has happened. Then a separate ECM is there for the entire control panel, or the entire display panel of your car, called instrument cluster, and which displays only the warning lamps. It doesn't display the engine temperature or engine coolant temperature, but only when its range goes out of range, beyond the range specified, then it will give you a red flag. A small bulb or a warning will be there. So nowadays the control panel or your instrument panel has become so advanced, so digitized, and except the speed and your engine speed and other thing, nothing is visible. Nothing is visible, and only the required parameter that you want, you can get it to be displayed. So that for that you are using a separate ECM. And then driver alertness monitoring system, where it looks into the driver's eyelash and its frequency of blinking, and then tells whether the driver is about to sleep or drowsy, etc. And some systems are there are alcohol detections is also available, and that's head-up display. That is again another drowsiness identification, whether your head is straight ahead or your head is going down, and these two are for the sleep detections. Okay. And night vision, that is available in your glass panel itself, where the night vision glaring will be avoided using this night vision. And sometimes a thermal scanner will be there, which will tell you about the hidden objects or any animal that is available in front of you. So a separate screen will be there, so it will look into the infrared waves, and as well as you will use the ultrasonic waves to detect objects lying ahead of you, which is not visible in your through your headlamp. and that's a special facilities available. Windshield wiper control, automatic rain. When there is a rain, automatically your windshield wiper will switch on using a rain sensor. Then parental controls, just like because there is so much of internet connectivity is there, and also the like a child lock system, parental control can be there, and sometimes the children cannot come out of the vehicle when the parent control system is activated, because they have the heavy traffic, they may come out and then get into accident. That is that. And then engine control system, this is the one of the older system introduced in the vehicle. And then for the airbag deployment, a separate ECM is there. And adaptive front light control systems, where the dip dim and then intensity of your headlamp beams are controlled by this. And then adaptive cruise control systems, which is there for most of the vehicles, where you need not worry about the maintaining a particular speed. This is a very important feature available for certain model cars. So this is what happening here is, when you travel in a highway, you are maintaining a 70 km or 80 km speed, and always you have to press the acceleration pedal to maintain the speed. The minute adjustments you have to make in your acceleration pedal. So here, when you activate this cruise control, it will take care of the speed range that you are setting. Suppose the vehicle is set in for 75 km, and it will meticulously follow the 75 km speed, and you can take off your leg from the accelerator. So the automatic acceleration, deceleration will be done by the cruise control. Not only that, suppose a vehicle that is in front of you travels only at 60 km, and your speed is 75 km per hour. What will happen? It will adjust the speed unless otherwise you change the lane. It will adjust the speed of your vehicle to the vehicle that is going in front of you. And once that vehicle goes away, then your vehicle will come back to the original level. So much of facilities there. And adaptive cruise control system is one facility that makes you comfortable driving in highways. And automatic braking is the thing already done. So I think I took nearly 20 minutes to explain about the various systems, and still more systems been added for an autonomous vehicle. So just it's a very big area, and that's why they say that electronics are costing more than the actual car. So actual mechanical parts of the car. So initially they were told that 25% of the cost goes to electronics. Now it becomes 45% in future, and this may gets reversed. All right. Okay, and just I listed some of the modules. So what happens? All these features, what I explained, they are being controlled mostly by the separate modules, the separate systems, which takes the input from specific sensors as well as the common sensors that is available for most of the modules. For example, engine speed or vehicle speed is main input for so much of the modules. Your engine control module will take the vehicle speed, powertrain control will take the vehicle speed, transmission control, electronic braking control. So almost most of the control modules will measure that, will take the input, one of the input as the vehicle speed. So a single sensor output can be replaced by many of the modules. So just I wanted to stress you that sensors are not meant for a particular control system. So sensors are the output coming from the sensors are common for many of the modules, and some sensors may be specific for a particular module only. So that point I wanted to stress. So you have more than a dozen modules in the vehicle, which does a specific function. Each one is doing a specific functions. And then there are certain specific sensors more than the common sensors. There may be a common sensors like a temperature sensor, pressure sensors, and then speed sensors, and then angular moment sensors, etc. So temperature sensor, you take that there may be more than a dozen temperature sensors are available in your vehicle. So the output coming from the sensors have been fed into the common CAN bus, and any of the module can take that value for their processing. Apart from that, certain specific sensors are employed in your car. So this figure depicts the specific sensors for a particular purpose. For example, starting from the lower end, headlamp range sensors. So if this sensor will look into your current position of the headlamp lights, how it falls, how far it falls, and whether the height has to be adjusted constantly. This is called the automatic headlamp adjustment system. So for that purpose, this particular sensor is used. So the height of the sensor depends on your road conditions, depends on your tire pressure conditions, can be adjusted so that your full visibility will be available for that. Then transmission system sensor is specifically used for the automatic transmission system, which will tell you about the torque transmitted as well as your temperatures and then the particular type of gear that is being engaged or not. The transmission system is for that purpose. And then acceleration pedal angular sensor. So this is particularly used for the engine control module. Your driver's intention is measured by this angular sensor. So whether the driver wanted to this pressing the pedal, acceleration pedal slightly or fully. So it depends on the level of is pressing. The angular position of the acceleration pedal is going to get changed, and that is going to determine your engine control module's output. So that is one of the special sensor or a specific sensor used for the ECM. And no other control module is going to use this particular sensor's output. And then mirror sensors, and this is again only for the automatic dim and reflection range, what you call the mirror control. So module will be using this mirror sensors. And then wheel speed sensor are used by 2-3 applications, like your ABS will be using the wheel speed sensor. For electronic stability program, the ESP will be using this one. Active suspension system will be using the vehicle speed. So 2-3 modules will be using this vehicle speed sensors. Okay, and the fuel level sensor is it's not very much used by others. Only the display control more your what do you call dashboard control ECM will be using this one. Now the fuel levels are not only being displayed as the off tank or full tank, etc. Now we are going to the level of identifying that what is the empty level, what is the future kilometer that you can travel with the existing fuel, and what is the economy you are getting. So nearly 3 or 4 parameters you can calculate by using this fuel level sensor. So for that, this sensor is being used, that will give the output only for your particular applications, particular display applications, not for others. And then if
excuse me, sir, your slide. Excuse me, sir.
I am using a typical sensors for the car. Slide number 3 or 5. Slide number 5. It's not visible.
So your slide hasn't moved yet, sir. It's still in the beginning, the introduction slide.
No, I have moved the 5th slide.
Could you make it a full screen and then try moving it, sir?
Okay. Now it's visible.
Okay, sir. Now it's visible.
Now let me see. It's visible now.
Yes, sir. It's visible. It's in the 5th slide now. Thank you, sir.
Thank you.
Yes, sir. Yes, sir.
Okay. Now, sorry, I didn't know. So, any problem? Because I am just looking into my screen and I'm just explaining, assuming that everybody is looking at the same screen. So, probably I will tell you the screen, the slide number, and you'll be able to check by yourself.
Sure,
So
sir.
I'm in slide number 5. There are it displays the typical sensors for the car. So what I told that the sensors are various sensors being used in automobile. Some sensors are common for so many modules, and some sensors are specific for a particular module. So that's what I'm trying to explain. And for example, a steering sensor is used for automatic steering control system, as well as for your lane correction module will be using this. And then HVAC is the heating, ventilation, and air conditioning sensor, which will senses your humidity level, O2 in your compartment, and also the temperatures, and all of these things will be sensed by the sensor, and accordingly your air conditioning system will function and will try to adjust the air quality that is available in your car. Then TPS, or the throttle position sensor, is mainly used for your engine control module, where the present level of throttle will be adjusted and will be measured by this TPS sensor. And then compost sensor for steering torque. So this is again used for only the lane correction sensors, as well as automatic steering system will be using this sensor output. How much torque you are applying, and accordingly the automatic steering system or your power control steering system will rotate your wheels by sensing your torque. And then differential non-conducting angle sensors, and this particular sensor is used for our crash detections. Non-conducting angular sensors, whether vehicle is moving in a straight line or moving in an particular angle. So it's called a gyrometric sensors, also used for the same purpose. And then motion position sensors, your vehicle's movement, and whether it's acceleration level, deceleration level. These things are measured by these sensors. And chassis level sensor are used for automatic spring rate adjustments or active suspension systems, where it will try to adjust the clearance between your vehicle and then ground. Okay. I am moving to the next slide. How is this possible? Okay, I told that so much of electronics, so much of facilities available in our car, and how this is being possible. How this is being possible. I think the next slide moved it. Slide number is not displayed. It's not visible for me. Need for the sensors.
So the slide hasn't moved, sir.
Has not moved. Maybe some problem with this. Okay, I will use this screen.
Okay, sir.
Is it comfortable to you?
Yes, sir. Now it's visible.
Okay. So how all these facilities are possible? And that's possible only by the use of sensors. When there is no sensor, there would be no automation. That's a very aptword. For even a small feedback control system, you need a sensor, you need a processor, and you need a actuator, and also a feedback signal. So within the simple sensors, you are to use the concept of sensor. Okay, what is a sensor? So by definition, a sensor is a device which provides an usable output in response to a specified measurement. So you give a input or a change in the environment, which will be sensed by the sensor and converts into an output meaningful signal. So that's how you have to get the definition from ANSI, American National Standards Institute, which defines most of the electronic component or parameters. I think ANSI is like a Society of Automotive Engineers. They do a lot of standards and terminology definitions. So the sensor is a device which actually responds to a given input and gives out a meaningful output. Most of the time, the meaningful output is in the form of electrical signals. That can be used in any of the visual, bridge, and other signals. And the sensor acquires a physical parameter and converts it into a signal suitable for processing. That's very important. So the further processing should be easy, made easy by the sensor, and you need not put another intermediate material in between this. Maybe certain amplifiers and processing system can maybe there, but otherwise the sensor should give a measurable and quantity. And there are certain things called transducer. So transducer is a device that is actually inside your sensor. So like a microphone or a loudspeaker, which actually a transducer, which is a vibrating membrane, which vibrates in response to the changes in the sound level. So and converts this sound level into an meaningful continuous electrical signal, which can be reproduced or which can be processed further. And the loudspeaker is an actuator. It's like an actuator, even though we say that it's transducer. It responds to your electrical signal coming from the control unit, and it vibrates and creates noise. So that's how they define. And I change the slide to next slide. Detectable phenomena. So all these sensors works based on a certain basic principles, basic stimulus. We call it the stimulus, like an acoustic stimulus may be there, or electric or magnetic. Any change in this parameter can be used to measure the various other parameters. Like for example, any change in the electric level, like a current or voltage, can be used to find out the changes in your motor position or a solenoid actuator, etc. Are you getting the changed slide? I am in the detectable phenomena slide. Now it's getting changed now. Okay, and then there is a thermal stimulus is there. Then the temperature of the object can be measured, or a flux can be measured. I think specific heat capacity can be used by finding out the thermal properties. So they work on the various stimulus. And again, the basic principles, different laws, different basic principles are employed in making the sensors. So Ampere's law, the current carrying conductor in a magnetic field experiences a force. So we make a galvanometer. This is a general, we are talking about in general, not specific to the automobile, but some sensors are specific to the automobile. So an Ampere's law states that the current carrying conductor in a magnetic field experiences a force. And similarly, D'Alembert's law. So the galvanometer works on the principle. Then Curie-Weiss law, there's the transition temperature at which the ferromagnetic materials exhibit paramagnetic behavior. Can be used. Faraday's law of induction for a transformer, and then photoresistor uses the photoconductive effect. So, and so each sensor can be made based on this principle. How do you choose the sensor for a particular purpose? So based on the environment, it has to work, whether high temperature range or corrosion, and the overall any electromagnetic interferences will be there, preparedness. Then the cost, availability, lifetime, and the sensor characteristics, sensitivity, range. You need not have a high sensitivity sensor for a rough estimate of the temperature, but certain temperature ranges or temperature measurements require high sensitivity. So that sensor characteristics also plays an important role in selecting a particular sensor. Repeatability, linearity, response time, and response frequency, etc. So all these things decide to collecting the sensors. So when you take temperature sensor, there are many sensors are available, and based on that you can the changes in the resistivity, the electrical resistance, and then strain. These temperatures can be measured. So this is a very simple sensor used in thermostats. Probably you may experience that in what you are using in your iron box, the common iron box that you are using in your house, and will have this kind of biometric stick. So this is acting as a switch for your iron box and also a sensor for our automotive purposes. So we do have a thermostat, mostly a mechanical one, where when there is a particular range of temperature, it will not open the gate. And when the temperature range is beyond certain level, it will open a gate and allow the water to flow in a particular direction. That's what used in a cooling system. The hot water coming from the engine is redirected back into the engine when the water temperature is below 85 degrees centigrade. So during starting time, the engine temperature will be below 85 degrees centigrade. So most of the water coming from the engine will be diverted back into the engine so that it is getting recirculated without going to the radiator. So the water will not be allowed to the radiator. So the water coming from the engine cylinder head will be fed back into the bottom line of the engine. So the same water will be recirculated. By doing this, we are trying to heat up the water quicker. That's called the warming up of the engine. So for that, the thermostat will sense the water temperature, and if it is below 88 degrees centigrade, it will not open the gate for the radiator. So once the water level increases, then it will open the gate. So this kind of sensors a control system can be used for your vehicle. And this is another temperature sensor working on the resistance, RTD, resistant temperature sensors detector, and works on this principle. When there is a change in temperature, the resistance of the material gets changed, especially semiconductor material. That property is used. Probably you would have studied about this sensor. And another special sensor used for our vehicle is automotive sensor or acceleration sensor. So this is a very small sensor coming under the class of MEMS that we will see at the later stage. I am at this acceleration slide, I think slide number 15. I think it's visible to you. So here the movement of the mass inside a closed container will be sensed by the changes in the capacitance. That's the principle. The vibrating base is that over which this is mounted. You see the small diagram on the bottom of the figure slide, and with a mass and a spring rate of K, and then the capacitance P. All these things will, the capacitance will get changed when there is a vibration of the mass. So that's how the entire acceleration sensor is used or working. And this accelerometer is useful in triggering your airbag system. Not only that, in identifying the other airbag system. This is not a single sensor. More than 4 or 5 sensors are employed in all over the sides of the car, so that each sensor will give you the lateral acceleration and linear acceleration and deceleration of the vehicle, and that will be forming the input to your airbag system. Then light sensors also used, which works based on the principle of falling the light in your sensor. So the day or night can be distinguished between these two, and automatic switching on the headlamp and then automatic switching on of your floor lamp. When you open the door, your floor lamp will be glowing. Okay, so that is being done automatically. Only during the night time it will be glowing. Daytime, when you open the door, the bulb will not be illuminated. So for this, you use a light sensor to sense whether it's a day or night. And also another light sensor is used in the headlamp controller, where the intensity of the light coming from the vehicle that is traveled from the opposite direction will be sensed by this, and accordingly it will dip and dim your headlamp intensity, light illumination. So the dipper dimmer of your vehicle, automatic dipper dimmer works based on the one of the input coming from the type sensor. Then magnetic field sensor will tell you that it's called also called the Hall effect sensor, which is used in speed measurement, and then your proximity of any objects, that's also being used in this one. So vehicle speed and wheel speed are measured using this principle, magnetic field sensor. Then you have the ultrasonic sensor for a rear parking, and then front object directions. Ultrasonic detectors are used, which will sense out the ultrasonic signals, and then say the reflected waves are being measured. By analyzing the reflected waves, it can tell you that what is the distance of the object, and by comparing with the timeline, it can tell you whether the object is coming towards you or moving away from you. For a short range, ultrasonic sensors are highly accurate, and it uses a wavelength of somewhere between 2 to 13 megahertz. Okay, and new addition, and for autonomous vehicle, this is also a standard feature. Okay, and then you have the gas sensor. So O2 sensors and the CO2 sensor, NOx sensors, like this. So many sensors were used in your vehicle as a feedback control. So, for example, O2 sensor is that which measures the oxygen level in your exhaust gases. So, normal atmosphere has around 21% of oxygen, and then this oxygen level changes when the combustion is taking place inside the engine. So the 21% of the oxygen that is going into the engine gets converted into carbon dioxide and NOx and carbon monoxide. So only a certain level of oxygen is coming out of this. And normally 8 to 9% is coming out of the exhaust, and that will tell you about the level of combustion that is taking in your combustion chamber. So for an engine control module, this is a very, very important critical feedback signal, and your entire ECM works based on one of the main output coming from that O2 sensor. Of course, there are other dozen sensors available, but O2 sensor is one of the feedback mechanism that directly tells you about the action. So each cycle, each instant that has been your fuel being injected is getting corrected by this O2 sensor output. Okay, so that's very important sensor being used in your vehicle. And then CPS, crankshaft position sensor. This is going to measure your crankshaft position. This is for giving a ignition timing as well as injection of your fuel. This sensor gives the input. And then camshaft, that's also important. Some vehicles are equipped with the automatic or camless valve system. For that, the camshaft positioning has to be done, has to be measured, and sometimes the what you call camless valve injection system will take care of that camshaft positioning and inject the fuel or open and close the valves according to the camshaft positions. So separate sensors are used. Okay, so there are still more sensors are available, and since time is not that for discussing all the sensors used in a vehicle, I told that there are hundreds of the sensors being used, and the temperature sensor, if you take on the range and then sensitivity that you repair, may have for the various temperature sensors they are used in a vehicle. For example, the temperature sensor used in your engine lube oil temperature is different from the sensor used in your temperature of your car compartment. So a passenger compartment temperature is measured by another sensor, which is quite different from the lube oil temperature sensor. Okay. And let us see the one or two example how these sensors are used in controlling the in a particular parameter. For example, I taken the engine control module, which is very, what do you call it, a basic, very important module, equipped in almost all the today's vehicle. Even in a low model vehicle will have an engine control unit, because nobody uses carburetor now. So when you replace the carburetor with a MPFA system or a GDA system, and also you replace the distributor with the electronic ignition system, definitely an engine control module system has to be there. So what is it doing? It is actually calculates the fuel quantity and sends signal to the relays. So there are two separate modules are there. One is for the ignition control and another is for the fuel control, injection control. So this particular engine control module is for controlling the fuel injectors, so that the quantity, quality and the timing of the fuel injected into the engine or manifold can be preciously controlled and makes the best performance coming out of your vehicle. Okay, so to make, and also it gives a signal to other control units like the ignition circuits, spark plugs, fuel injectors, and etc. You see then this next figure, slide number 24. The engine control module acts as a central control system, and so many other control modules are taking input from this one. So in the sensors used by the ECM, engine control unit, also being shared by other with the other control units. So when you sensor the tick signal, it will sensor the reference to the sensor input also. Okay, in a sensor's output also. So that's a concept being used in automobile. An individual control unit doesn't function individually. It will function with respect to the response or input that you are getting from other ECM also. Because a car functions as is a highly what do you call it, a complex nature. For example, if you want to accelerate the vehicle, you have to take care of the so many other parameters, whether the braking is being released, whether the transmission system is available now for acceleration. Simply you cannot pump the fuel. Okay, so slowly, gradually it has to be a particular rate only, the quantity has to be increased, and that rate will be decided. One of the deciding parameters is how much torque is transmitted into your vehicle, the transmission system, and what is the current level of your vehicle's gear position. So many other indirect performance is also being parameters also being measured and taken care in controlling the fuel injection rate. Okay, so this tells you about this diagram, slide number 25, tells you about the processing, how it is being done. So the sensor senses the various parameters, gives it to a controller, where the controller will have a signal conditioning system, analog to digital conversion, digital signal processing, and then control functions, voltage reference values, and then bias configuration, which gives us the feedback to the sensor to correct itself for the bias measurement, and then the output goes to the digital interface and analog interface. From there, it goes to the actuators. Okay, and the control interface is for the other modules. Other modules also shared by the output or input received by the particular module. So this is a very elemental explanation. So a sensor input is taken for after conditioning the input signal and convert into analog to digital, and a signal processing along with the signals obtained from other modules is processing this, decides, takes a decision and sends the decision to the actuators. Okay, this is the condition of the engine, this is the condition of the vehicle, and this is the driver's intention. So you inject this much fuel. So like that, the decision will be taken and will be relayed to this. Okay, and for this thing to happen, various sensors. You see the list of sensors being involved. I think there is an separate list is there. So pedal position sensor, throttle valve position sensors, engine oil temperature sensor, O2 sensor, induction air temperature sensor, EGR sensor. EGR is the exhaust gas reflection sensor, oil pressure sensor, fuel level sensors, wheel speed sensor, torque sensor, NOx sensor, airflow sensors. So you see more than a dozen sensors being taken care and the inputs are processed. And each sensor is having a parameter that is been monitored. And for example, engine speed control monitors engine speed and throttle position monitors the throttle position. NOx sensor detects the knocking in your engine, etc. So by using all these things, the signal is given to the actuators. The actuators is your decision is conveyed to these actuators, and there the electrical signal is converted into a meaningful mechanical signal. So the fuel injector will start injecting the fuel. A spark plug will start giving the spark at a particular time and duration. And EGR valve will open or close and allow the amount of percentage of EGR being circulated. And then your fuel tank venting. This is a very important part of your engine control module. Today's software requirement requires a separate evaporation control system for the engine. So the evaporation from the fuel tank or any other fuel handling devices has to be controlled by accumulating the vapors and sucking out the vapor. It has to be burned. The fuel vapor that is coming out of the tank has to be collected in a canister, and that has to be purged periodically, and so that it goes into the engine and burns out. So at no instant the vapor should not be allowed to escape into the atmosphere. So for that you have the venting actuator is there, and then cooling fan, by switching on or offing the switch off the cooling fan. Then starter motor, because unless otherwise engine control module gets activated, starter motor will not function. Throttle position. So starter motor is giving a signal only through the EGM. Throttle position motor. So the throttle position is changed by electric motor, stepper motor, which will get the signal from this one. Then apart from this, there will be a check light in your compartment, in your dashboard. So that is also actuated by this. So you see that by taking the input coming from a dozen sensors, more than dozen sensors, the engine control module is able to take a decision and gives out appropriate signals to half a dozen actuators. Not apart from this, it communicates the decision that it has taken, the input parameter that is it has obtained into a common data bus, and which is a special bus used in automobiles called CAN bus. It's called the controller area network bus, and rather than, and also sometimes a LIN bus also being used. But mostly automobile system, they use the CAN bus to communicate with the other ECMs. Okay. So, and also the engine control system, apart from the sensors, takes the input from the some switches. This is to make it safe for the vehicle to be moved forward. This is like I can give an example for this. In some of the two-wheelers, when you have the button start for the engine, and if your vehicle is put on a gear or a stand, the engine will not start. Okay. In some two-wheelers, they made a system that unless otherwise you take out the side stand, you cannot start the engine. That's the one thing. In some systems, some vehicles, unless otherwise you put the vehicle into neutral position, you cannot start the system. So a separate switch will be sensing your position of the air conditioner or a air conditioning clutch or a brake on off, whether you press the throttle for a wide open throttle, or whether the throttle is completely closed, or the parking position has been put on, or the gearbox, the gear is not in neutral position, like a side stand, if it is whether the side stand is switched on or put it on position or off position. So all these on-off conditions, these are all on-off positions. So there is no gradual movement. So that's why we call it a switches. What is the difference between switch and a sensor is, a sensor can sense the variations, but a switch will sense only on-off. So there it works on this one. So this is the diagram which depicts that very simple, what do you call, control systems used and the layout of the components. This is what you can learn from this module is, in this figure is, the where is what. So you have the ignition coil for giving the spark plug, and then you have the throttle position sensors which is placed along the inlet air, and there is an injector, a spark plug, and you have the fuel pressure sensor. Not only the fuel level, pressure sensor is also important for an injection system. So your system has to work on this one. Okay, then exhaust O2 sensors and then exhaust oxygen sensors. Between or two sensors are employed across the catalytic converter, so that the effectiveness of the catalytic converter is also monitored continuously, and when the effectiveness gets decreased, and your sensors will give out that signal. Okay, and this is how the engine control modules will look like. Yeah, separate box. And if you look at the front end, there will be a 24 pin and 36 pin connectors will be there, which is a special feature for the CAN connections. It generally uses a 32-bit, and now people are going for 64-bit microcontroller also, with a few megabits of memory, clocked at speeds between 32 megahertz to 100 megahertz. And they generally communicate with other ECM through CAN bus interfaces. In case when the engine control function and transmission control functions are combined in the same module, it's also possible. Some manufacturer will combine these together, generally referred to as a powertrain control module. So the name will get changed when you have the ECM combined with the transmission control module. So ECM is the power control module is the name that you will get it. And we'll skip this one. Again, there are various sensors figures, and that is used here. And Bosch, they put separate sockets for the CAN and the link buses, input sensors. This is one of the pressure sensor, what you call a slow pressure sensor, where there will be a diaphragm, and the movement of the diaphragm will be converted as a capacitor. And this is the piezo pressure sensor used for knocking in your engine, and the piezo crystal will be inside. It can withstand up to 400 bar pressure. So high cost pressure sensor, and the acoustic sensors been used in your exhaust tailpipe, where the piezo electric low pressure sensors will measure the acoustic waves. Okay, one more example is that, I don't know whether we'll quickly go through. This is called the electronic stability control system, so which it makes your vehicle to be highly comfortable and make it travel in a straight line without slipping. Okay, so sensor used in the stability control include accelerometer, a steering angle sensor, wheel speed sensors, hydraulic modulators. This is that. Because of the hydraulic control system, the modulator is also used as an input signal, and then a yaw rate sensor to see that whether his vehicle is being tilted. So the functions are explained here. So the name indicates the steering wheel sensor will measure the position of the steering angle. Yaw rate sensor will measure the yaw rate, and lateral acceleration is sensed by the G sensor placed at the side of the vehicle. And wheel speed sensor, steering rotational speed sensor, So all these things are giving input to the electronic control module, and then it will be sent to the sensors, and then goes to the actuator to take the corrective action. So you see that there's a closed loop happening between the controlled unit and then the vehicle, and then your sensors and actuators. So all these things are connected together, and a corrective action is continuously being taken by giving the signals to the actuators. So a sensor will sense the what is the current position and gives the signal to the sensor, and from there the decision is taken and it goes to the actuator. From actuator it goes to the vehicle, and then this system continues. And another is safety sensors. Special sensors are used, and all these sensors seems to be a bigger size, but there are dozens of very small sensors are employed in that. Sensor itself will be in the millimeter range. So that's called micro electromechanical sensors. MEMS, micro electromechanical sensors are used in automotive extensively right from the middle of the last century. And you see the list of sensors that is being used or developed in a particular years. Okay. And then so MEMS are used almost in all the electronic control modules, because these sensors are along with the other sensors help you to make work with the signal for this one. Okay. So similarly, vehicle dynamics control is used, and I think vehicle navigation systems. We'll come to the rear end of the yeah. So this I wanted to stress you. The future vehicle will have, in addition to the normal sensors, some important special sensors will be employed in these vehicles. So it's called the autonomous vehicle, and these things are they have the active sensors will be there. Okay. So this particular slide number 69. Kindly move to slide number 69. I think it will be visible to you. So this figure tells you about the various sensors being used in autonomous vehicle. Okay. So you have the camera, which is a sensor for the visible range, and you have the another camera for the wide angle and narrow angle, and you got the GPS system, and you have the ultrasonic sensors, and you have the lidar and radar systems, and then infrared sensors. So much of sensors being employed to move the vehicle, to see the vehicle autonomously, and then process the signals and understand the environment and take a decision to move forward. So this is what explained here, and I am leaving this material with you. Right? I didn't have much time to explain all these things, because this is a very big topic, and we took 15 days to explain on the various features in an autonomous vehicle alone. Recently, we conducted a seminar on the autonomous vehicle, and we have taken experts from various places all around the globe. People from Germany and US, they have participated in these discussions. And for autonomous vehicle alone, so much of material was discussed, and so trying to put all these things in one of our session is difficult for me. Anyway, I think I try to cover most of the things, and at least you understand that sensors are a very important part of the automation, and there are a dozen sensors, more than hundreds of sensors available, and some sensors are specific for a particular purpose, and some sensors are common for many of the application modules. That's it. I'd like to share with you. If you have any queries, we'll take a few minutes to complete the query. Any
Sir, I
queries?
don't think anybody has any queries. No, sir, I don't think anybody has any queries. We
I
can
don't know
end
whether
the session, sir.
people are here, and I don't know whether they are actively listened or not. And I don't know.
So we are here.
Okay, I think you will have a formal feedback from the people. Get it?
Yes,
Thank
sir.
you. I'd like to thank Dr. Balakrishnan and his team, and Sachin and other professors who has invited me to participate in this series of webinars. I'd like to thank them, and I'd also like to thank the management of the AICT, and I think this is sponsored by AICT and
Yes, sir.
associated people, and people who are I think one of your faculty is presenting. We are coordinating the links. And thanks all of you, and thanks for the participants also for your passionately listening. And feel free to contact me anytime regarding the other doubts. Thank you guys, and have a nice day. Be safe.
Thank you very much, sir, for a valuable session. It was very useful for us. Thank you, sir. Shall we end the session now, sir?
Yes, I am logging in. Thank you.
Thank you. Please, participants, the feedback link has been shared in the chat. You can please fill the feedback session for this 12th session.